Okay, cool. Um, I've been using Cursor and Claude Code, Codex, and all this stuff for a while now. And then I've always thought, like, why do we have so many other tools? First thing, maybe because of corporate people have to be on the, race with this agent coding thing. But cool. But if you think about it, they all have their own way of handling things, right? So if you just separate them, separate the pieces together. If you take Claude Code or Cursor, start pulling down the pieces, and then if you'll be just left with the base models, not base models, LLM APIs, because base model is different. So you just have LLM APIs. So they take LLM APIs and then build the infrastructure or the orchestration on top of it, right? So I've been using Cursor especially for a while now, and then I I was just fascinated by a couple of things. The first thing I was fascinated by was the model switching. So I don't know how Cursor was before, because I haven't used Cursor before. I've started using it now, but I've used Codex and Claude a lot. So I switched model, okay, and I'll tell you what, I was using the default one, that is Composer 2. Then I switched to Claude and then I switched to GPT because of some task that wanted some higher context window and everything. Then I realized that the switch happened instantly. This is the first one. And then it it didn't even forget the context. And whatever the next content or the tokens it predicted, they were all kind of aligned with the previous conversation. So this is not very easy to do. Okay, I have no idea how it works in behind the scene. I had no idea before. Okay, now I have. But before, when I had no idea, I kind of realized it's not a simple thing, first of all. And it was so good. Okay, it was just fascinating. So I started digging deeper, and while doing that, I kind of got this interest, developed this interest around agent harnesses. So I'm not talking about this trending topic now, like harness engineering or prompt engineering and all this stuff. I'm not here to like talk about that. Okay. All I'm here to talk about is the experiences I had with this thing and then what I've decided to do with it. So these things, right? The harnesses, right? That's the main engine, okay, with Cursor. Harness. So harness, what happens here is that let's take a simple LLM API here. LLM API, right? So you have a simple LLM API. Give me a second. Give me a second. Let me pull up my notes. Right. So you have an LLM API. So this can be anything. Okay. This can be your Claude, GPT, whatever it is. So then comes context layer. So because you need a way to send context. So let's say context. So this context here can be anything. So can be like the conversations you had with the agent, and let's say Cursor or Cloud Code or Codex, whatever it is, as a way to store these contexts somewhere. Okay, so let's say they're indexing it. It can be in a vector DB or some strategy of their own. And let me tell you one thing: there is no one single strategy or one single standard way of doing this. Okay, Cursor has a different way of implementation. Cloud Code and Codex has a different kind of implementation, but the mental model is same. So whatever the context, let's say you chat about, hey, my name is Pavan. Okay, this is one context, one message. And then you ask about, hey, my age is 25. And then that's the second message. Now let's say the agent replies here. Okay, it says, okay, okay. Then you say, hey, what is my name? Okay. So let's say you're not storing any sort of context. Okay, so every message you send is a new thing. Then what happens is, by when you send first message, it'll say okay. When you say second message, it'll say okay. When you send third message, like individually, it doesn't remember your name at all because it has no idea. Okay, I'm talking about LLM APIs, base APIs. I'm not talking about Claude Code and Codex here. And just to be safe, Claude Code is different from Claude. Okay, Claude Code is a product, Claude is an LLM. Okay. Now, what if you send all these three things together? So let's say I send this first. Okay, I send this first. And while sending the second one, I'm gonna attach the first one automatically without you knowing it, and then send these both together. Now, the LLM API or the LLM behind this API remembers that, okay, the username is Pawan, and now they're telling me the age is 25. So Pawan's age is 25. So it will understand that. Then, if you send this message, oops, if you send this message to them, okay, combining all these three things, then if you ask what is my name, it will say, hey, your name is Pawan and you're 25 years old, 25 years of age. Okay, that's what it will say. So let's see the difference here. Okay, this thing might be very simple for you. It might say like, oh, what big deal, just sending history of the conversation. That's not the point. The point is that you just orchestrated something. Okay, the point is you just orchestrated a conversational history so the agent remembers it. This is called I don't know if I'm supposed to say it this way, but it's context engineering. Okay, hopefully it's correct, because that I don't know, like I don't think writing better prompt. Okay, that's prompt engineering, but yeah, this is like context engineering, like deciding what exact data you want to send so that the current query gets proper responses. Okay, so this is what context engineering is, and this strategy or this particular feature is baked in for you in harnesses. Okay, so when in the context layer, all these things are baked in for you. So let's call this as vector db. Cursor uses turbo buffer, if I'm not wrong. Yeah, turbo buffer for this. So they just store everything here, and then they have their other strategy as well to retrieve proper valid context only, not like everything. Okay, they have like some more advanced orchestration on top of this. So this is what the context does. All right. So next step, you might have like a tool calling. I'm gonna just write it here. Just put this here. Okay. Next up, you'll have something like a tool calling or something. Okay, so tool calling in a sense, it's just like if you say like, hey, where is this variable declared in my code base? So the agent would say, okay, they're asking where is this particular variable declared. So now I need to search the code base. Okay, that's what LLM would think. Okay, I need to search the code base. Then it will say, hey, how about you do this function calling? Okay, I'm going to explain a bit deeper here, not deeper in a brief. So let me write tool calling here. So for this tool calling to work, there's only one important step, that is system prompt. So let's write system prompt here. Okay, system prompt. I'm going to call this SP. So the system prompt will be fed into this LLM. Okay, by default, what the system prompt will contain is, it will contain details about what exactly is the system. Okay, system details, like who are you, like what is your actual goal and stuff like that. If that's optional, but people usually add it. And then tools available. Okay, because by default LLM doesn't know what are the tools available. It knows like how to call a tool, okay, but doesn't know what are the tools available. So let's say in tools available, you're gonna say files API. Okay, files API. So now what happens is, when you say find this variable for me, LLM API remembers that it has a tool called file API or the file system or something like that. And then you can say, hey, how about you call the file API with this parameter? The parameter can be find, and in the bracket it can be the word, variable word. And in this tool calling will have scripts. Okay, scripts or function or whatever you want to call it, like a JavaScript function or whatever you want to call it. It will have that. Okay, so called as scripts. Okay, it can be like things like grep. Okay, if you call grep, it will invoke command line, command prompt, or so like Unix command and stuff like that. Okay, and things like copy, things like move, and all those stuff you have, right? If you want to create a file, let's say you use touch or something like this, or maybe you use different. Okay, it depends on the LLMs and different on systems also, because Claude Code has a different way of searching for file systems, and Cursor has a different way of searching for file systems. Okay, and all these data, okay, are provided by system prompt. Now, when you provide system prompt, LLM knows that what are the capabilities it has and what to do with it. Okay, similarly, you have lot of layers on top of this. Okay, lots and lots of layers. So one such layer is execution loops. So if you tell your agent to like, hey, loop over this until it's done. So execution loop will handle a couple of things, like it will verify each and every response you get. And if the response has, if the response is not like stop or something like that, it will reattach the context and resend the request again. So in your mental model, loop is like, okay, until this is done, keep looping. But that doesn't work in code, right? You need to like define like how to do it, define a way to solve that loop. So in that case, what happens, it's a simple mental model also. Just intercept the response you get from LLM, see if it is done or not. If it doesn't say done, then take whatever data you got, strip the unwanted stuff, resend the request again. So you keep doing this in loop until it says done. Once it is done, just stop the loop. So that's what this is. So this is what harness is in high level. Okay, I'm not complicating stuff here because harness is a bit complicated. Many people are trying to explain this online also. Like I've struggled a lot to understand this also. When I understood it, it kind of felt like I already knew it because it was that simple to in theory. Okay, not in code. So you have like a lot of layers and layers of functionalities, or I like to call this as orchestration. I hope spelling is correct. Layers and layers of orchestration on top of an LLM API. So all you get is an LLM API. Okay, even you can build this. Okay, so it can be like Claude or GPT LLM API, and then you build all of these by your own so that you can make it work the way you want it. Okay, and then if you think about safety, safety guard rails and all the stuff, right? Like let's say do not call rm minus rf, something like oops, rm minus rf, or do not push .env, or do not read .env, and all those stuff. So we're gonna add it here. Okay, in this also includes in the harness. So this was the entire gist of an harness. And why am I actually talking about this is because I wanted to build a harness. Okay, not because of building it as a SaaS product or something like that, in a business way. I wanted to build this because I wanted to learn the complexity behind it. And there are a lot of harnesses available also online, open source one actually. Not even you don't even have to pay for a harness; it's all free. But if you have a use case for it, you can use it. Or if you're just like a simple dev versus experimenting, then sure, you can also do it. But if you still want to experience harness in real time, use any of the IDEs, agentic IDEs like Claude Code, Codex, or Cursor. You'll experience it and then see like what you want to do with it. So in my case, why am I doing this is because I wanted to learn about harnesses. I knew the theory now, but I want to implement and learn about the nuances inside building harnesses because it's very challenging to build. And there are a lot of things that will go wrong. There are a lot of things that will show up which would eat your mind. And one thing I want to do is I want to limit myself using agentic coding tools here because they will just build everything. And since why am I limiting it? Because I myself don't have an idea like how to build them. Okay, if you take a feature, right, you'll have the requirements lined out completely, like what is it that the user want and what do you have to build. And let's say you will have a meeting with your tech team and product manager, for a day or two about implementation, like how to implement and stuff like that. So in that case, your clarity level is higher. Okay, you know the requirement, and then you know the implementation details also now. So the clarity bar is very high, where you can easily plan this entire thing with an agent because you are not outsourcing thinking here. You're only outsourcing the coding part. Okay, you're only outsourcing the work. You're not outsourcing thinking. You are thinking here. So that makes sense. In that case, using Cursor or Claude makes sense. But in this case, I have no clarity. I have a direction to start. So I'm going to start with context. Okay, I'm going to start with context like history and then context compaction. Okay, that's what I'm going to start with. So I have only the first phase direction. I don't have the next phase direction because I have no idea what comes next. And let's say if we start using agentic coding tools here, it kind of feels like I'm outsourcing my thinking capability as well for an agent. And I might trust whatever the agent says. Okay. So at least for this project, I might be overthinking, but for me, this is what the clarity I got, that I might have to code some of the things myself, not everything, because it's just waste of time. So once I have, let's say if I'm having enough context or enough clarity on a certain set of feature, I'm gonna just use Cursor and just one shot it. But if I'm solving some complex thing, I want to solve it by my own by writing the code so that I can understand how things are and then get some more experience out of it and exposure also. So that's the entire plan, and I'll be sharing the entire um, work that I'll be doing. So whenever I'm coding, I'll be recording. So I'm gonna just cut off a couple of stuff and then just upload it. So sometimes it might be long, sometimes it might be short, but if you find it helpful, it's good. If you have any suggestions or if I'm going in a wrong way and if you just want to correct it, that's even better. So consider supporting. And the first thing I'll be starting with is context. So this, the example that I gave you earlier. So it will be like history. So in a standard way, I'll be like persisting conversations in a simple SQLite. Okay, I'm going to be using SQLite for now. We'll move to advanced stuff later on. So SQLite to store all the conversation of a user. Okay, and then you can resume a session as well. Like you get a conversation ID or a session ID. You can resume a session if you want, and then compact context when we hit 90% window. So this is a bit tough, not because it's complex, it's straightforward actually. So you just compare the tokens that you're using. Let's say your agent LLM API supports 200,000 context window tokens as context window. So if you're hitting like 1000 900 and something like 90% of it. So you would just like create a new session, summarize this existing one, okay, or just like cut the older one and only preserve the newer history, okay, and then just share it. That's one way of doing it, straightforward way. Another way is, okay, so let's say your conversation is this long. So first way is you cut this part, and only use this in the next conversation. The next conversation start with this older, okay, and then whatever you do, it will continue, something like that. But the problem here is, if in case whatever you ask, if you ask something here which is not here, then it'll just, the LLM will start hallucinating because it doesn't have any idea about it. Okay. To solve this, the best way, not best way, one of the way is, so you divide these two things. Okay, you would divide these two things. So you would use this as it is. Okay, you would use this as it is over here that we're doing. Okay, and this will be stored in a file. Okay, in a file or a DB or somewhere. Okay, preferably vector, but let's say we store it in a DB for now. Okay, let's call it DB. It can be vector or whatever it is. We'll just call it DB. So the way you would build your harness is, if in case it's not here, then you search here. If it's case not here at all, then maybe deal with hallucination in a different way. So you see the problems, right? First problem, we thought we solved it, but then another problem came up. Then we thought we solved it, but then even if it's not here, then we have to deal with hallucination again. So in some other way, which I have no idea about. That's what I told you. I have no idea. I don't have much clarity on this. And I didn't even try to get more clarity because I wanted to run into these problems. So I understand how my cognitive capability is as well, because with this agentic coding era, the cognitive ability is also being in decline. So I want to run these problems myself without any idea and then try to solve it with my mental capability. That's the reason I didn't dive much, didn't get much context also. I only dive deeper to get the initial direction. And then I'm gonna start doing it myself. So of course I'm gonna refer online also, like if I'm going in a correct way or wrong way or something like that, and then try to like correct my direction. But this is what I'm doing. So this is it, guys. Just want to like give you an idea about what agent harness is, and at least what I've learned, and then what I'm building. So if you are someone who's also want to build something like this along with me, then tag along. Maybe you can just do a code along with me, like you're watching my video as well. And if you like this, do consider following. Okay, thank you.